In the last two videos, we talked about the slope formula and the distance formula. In this video, we're going to tackle the third of the big Cartesian plane formulas, which is the midpoint formula. Once again, write down what you remember about the midpoint of a line segment and how you think we can use it and how you think we can calculate it. All right, so I'll take my blank sheet of paper now, and here it's going to be a slightly different. All right, so once again, we've got 2 points, and we've got the point that's right in the middle. It's halfway between these 2 points, x1, y1, and x2, y2. So this point is exactly in the middle. And so the question is, well, the x distance is going to be half of the x distance of the whole side. And same thing, the y distance to the midpoint is going to be half of the y distance of the whole side. All right, so that gives us some kind of idea. But what I want to get at, instead of trying to go down this road, is this point is going to be exactly halfway. So let me say x, I'll call this x with a hat and y with a hat. So x hat is halfway between x1 and x2. Can you think about a mathematical operation that we've done before that helps us find the number that is exactly halfway between two numbers? Okay, for instance, if I had the numbers 10 and 20, what's something fast I can do to figure out that the number 30 is in the middle of them? I'll give you a hint. What I want to calculate is the average of x1 and x2. Because that's what it means for a number to be halfway between x1 and x2, is that it's the average of the two numbers. So what is our formula for finding the average of two numbers? Well, all we do to find an average is we add up all of the numbers and divide it by the number of numbers that we added up. And then the same thing is going to be true of the y-coordinate. The y-coordinate is going to be the average of the two y-coordinates. All right, so once again, let me write that down. I'll use big M for the coordinates of the midpoint is equal to x1 plus x2 over 2, y1 plus y2 over 2. And notice the similarities and differences here. In the slope formula and the distance formula, we were taking the difference between the x coordinates and the y coordinates because that was telling us about the lengths of these sides. The difference between the coordinates was telling us the length. With the midpoint, we don't really want to find the length and then cut that in half. We could, but a shorter way is just thinking about the number that's halfway between, which is the average. And that's why to calculate the average, we're adding the x and y coordinates. So that gives you a sense of why these two formulas are dealing with subtracting the coordinates, and this one is dealing with adding them. And finally, and once again, give yourself some notes for how you could remember this if you've got a blank sheet of paper and these were the only hints that you had. And what is the midpoint formula going to be good for? The same way that the slope formula is helping us figure out about parallel and perpendicular lines, distance formula is helping us figure out about congruent lines. What kind of concept were we learning about at the beginning of the year that would be covered by the midpoint formula? Well, midpoint is a word we were using in the beginning of the year, but a different one is that we can figure out if a line segment is bisected by a point. Okay, so if we've got the midpoint breaks a line segment into two line segments that have the same length. That's kind of what midpoint means. And that was what it meant for something to be bisected. So the cool thing is that these three formulas are helping us to take these concepts that we learned about in geometry from the beginning of the year, and they're letting us calculate whether they're true, given the coordinates of the points that are involved. All right, in the next video, we're going to flip this page over and we're going to look at the back, which is reminding ourselves a little bit of quadrilaterals. And when quadrilaterals, we're using words like parallel and perpendicular and bisecting and congruent. And we're going to connect all of the dots between knowing the coordinates of points and being able to determine if 4 points represent the corners of some special kind of quadrilateral.